Can you find the area of this blue shaded circle? We are given a window shaped like this. Inside this shape, two semicircles, each with a radius of 1 unit, are placed side by side along the base like this. Again, a blue shaded circle is placed in such a way that it is tangent to both semicircles and also to the inner arc like this. And the question is to find the area of this blue shaded circle. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let's get started. But before we begin, let's mark the center of this blue shaded circle and drop a perpendicular line on the base of this window-shaped figure like this. Again, let's define the radius of this blue circle as r units and the height of this perpendicular line as h units and construct a line joining center of this semicircle and center of blue circle like this. According to the touching circles theorem, that is when two circles touch each other externally, the distance between their centers is equal to the sum of their radii. And since the radius of this semicircle is 1 unit and the radius of this blue circle is r units, that means this distance between center of the semicircle and the center of blue circle will be equal to 1 plus r units, right? Now look at this right triangle formed between the radius of semicircle, perpendicular line, and the distance between two centers. Here the hypotenuse is 1 plus r units, base is 1 unit, and the height is h units. So using everyone's favorite Pythagorean theorem, we have quantity 1 plus r squared equals 1 squared plus h squared. Let us mark this as equation 1 and keep it here for later use. Now let's draw a line from this point to the inner arc passing through the center of blue circle like this. And look carefully, this total length here is 4 units. That means length of this line will also be 4 units, right? And since this part is also the radius of circle, that means this remaining length will be equal to 4 minus r units, correct? Again, look at this right triangle formed between diameter of semicircle, perpendicular line, and this new line. Here hypotenuse is 4 minus r units, base is 2 units, and height is h units. So again, using Pythagorean theorem, we have quantity 4 minus r squared equals 2 squared plus h squared, right? Let us mark this as equation 2. Now we have 2 equations and 2 unknown variables. So let's subtract equation 1 from equation 2, and we get the quantity 4 minus r squared minus the quantity 1 plus r squared equals 2 squared plus h squared minus 1 squared minus h squared. Simplifying this using algebraic identities and canceling h squared, we have 16 minus 8 r plus r squared minus 1 minus 2 r minus r squared equals 4 minus 1. Again canceling plus r squared and minus r squared, we get 16 minus 8r minus 1 minus 2r equals 3. Now simplifying this further, we have 15 minus 10r equals 3, and subtracting 15 from both sides we get negative 10r equals negative 12, or 10r equals 12. Now dividing 10 from both sides we get r equals 1.2 units. This means the radius of this blue shaded circle is 1.2 units. The area of a circle is calculated using the formula pi times radius squared, so substituting r equals 1.2 units, we get area of this blue shaded circle is equal to pi times 1.2 squared, which is 1.44 times pi square units. And if we take pi as 3.14, the approximate area becomes 4.52 square units. And that's our final answer. Pretty amazing, isn't it? Just few construction and right use of theorem gave us exact answer. But wait, before you go, here is a quick bonus challenge for you. Can you find the area of this same blue shaded circle in terms of a variable x instead of numbers? Think it through and drop your answer in the comments below. Let us see who can figure it out. If you found this explanation helpful and learned something new, do not forget to hit that like button, share it with a friend, and subscribe for more mind-bending math puzzles. Thanks for watching, and I will see you in the next video.